again, it's the same loop over and over again. What we do is I talk about through material, but again, we're trying to encourage you to move forward and get your feet wet into what's known as a computer algebra system. I'd say the number one reason is it's students that transfer off to NJIT often complain to us, particularly our better students will come back and say, I don't think it prepared us for NJIT because the students at NJIT have been dealing with a computer algebra system for years, and now I'm afraid because I'm not at their level. All right, and this is a terrible thing that happens to students. It's like you show up at a job and you realize the other people that you're working with are well beyond your skill set, and you know that presents doom for a lot of people. All right. We live in a very competitive market. So I'm going to say if you're interested in moving forward and we want you to move forward, it isn't like to say, no, gee, we just want you to stagnate and stay where you are. We want you to move forward. How do you move forward? You've got to start to study. You've got to start thinking outside of your box, including the box that your professors have set for you. Some of your professors have set a very, very low bar. All right, very low bar. You start thinking about a bigger world out there. The bar is really high up there now. People are working extremely hard to master this material. All right. So let me talk about this. If you want to, you can do the saved website, really the same thing. I like to use my computer to do the computations. So I'm going to kind of type this in, reset. I think I've done this many, many times before. I'm going to define the variables, by the way. You may wonder why that is. I just think it's a good habit to do so. So var, and what's that? U and V, right? Don't be intimidated by typing. You need to learn to type too. All right. So U is a vector. I think I can type that in. And you want to type it in too. So U is a vector. And what's the vector going to be? It looks like the vector 1, 2. And I think you can probably see I'm not a very good typist. I'm a bit slow at it. So what's V? V is also a vector. And I'm reading it to you. What's vector? I should spell it right, right? And what's that going to be? 3, 4. And I think we've done this before, right? Let me display U2. 1, 2, expecting that. And let me display V for you. 3, 4, I was expecting that. And let me do 2 star U. We've done this before. It's a scalar multiple of a vector U plus a scalar multiple minus 3 times a vector V. I think I can do that. I don't need a computer for that. Pretty simple. This is new for me. U dot product. I've done dot products before. I'm sorry, I spelled it. I'm sorry, I didn't spell it, but I doubled up the product. A dot, I mean. I don't want to do that. And what do I do? U dot V. All right. And remember, if I type something bad, it's going to basically say an error. That's not too bad. I can do that. And let me do square root. We'll talk about what these things mean later. And the U dot V, right? I'm just simply typing things in, see how good I can do with that. I think I could have done that too by hand. All right. And, maybe I'm a little tired. I'm going to start copying. So I copy this line. I want to tell you what this means, though. When I do U dot U and take the square root of it, it's the length of the vector U, square root of 5. All right. I'm going to copy this down. I'll talk through it. Someone says, why are you copying? I've already typed it, by the way. I actually type every single character in your notes. Every single character I typed. So what do I got over there? I'll read it to you. It says arc cosine U dot product V divide by the square root of U dot U. That's the length of U. Divide by the length of V. Well, you know what? That's the angle between U and V. That's a computation. So theta is the angle between the vectors U and V. All right. So let me type down theta, see what it gives me. See what it gives me. I don't like that. So what I'm going to do is I'm going to approximate it. I think we've done this before with the dot n notation. I don't like that either because it was in radian. So I need something that's more familiar to me. So what I'm going to do is convert it now to degrees. So 180 divided by pi. Now remember, if I do that, pi will be in the answer. So I'm going to approximate pi. So remember, n dot n, about 10 degrees. So I'm just going to scroll back in the notes. Sorry about that. I'm going to clear this. And what I want to do is I want to do problem number 11. Before I do problem number 11, though, I want to compute the answer to see what the answer is. And what's the answer? Arc cosine minus 11 divided by 5 divided by the square root of 34. Now remember, I want this to be in a decimal number, but I want the degrees. So n, and now I'm going to multiply it by 180, right? Divide by pi, but I want pi in my answer, so I'm going to approximate pi 2. Remember, if I type something in wrong, it's not going to blow up. It's going to say I made an error. So let's see if we can do the computation just looking at it. So what's it going to be? Well, certainly if you don't remember, go back, scroll in your notes, and the angle between the vector u and v it's really not bad. It's arc cosine u dot v. Let me write that down. I think I've just done that before, right? Oh, you know what? I've got to define u before I do that. So let's put u down. So do we remember how to do that? U is a vector. What's the vector? 6, 7, right? Let me type u, make sure I got that. That was pretty good. Let me type down v. What's v? V is a vector. And what's the vector? It's minus 3, comma 1. Let me type down v, make sure I did it right. I did a good job. So let's type it in now. So what's theta? Arc cosine u dot v. Let me write that down. U dot product dot product what? With v, right? Divide by the length of u. The length of u is going to be square root u dot product. Remember, if I make a mistake, it'll come up. Not going to blow up. I make mistakes all the time. U dot u. Divide by the length of v. Let me write that down for you. Square root of v dot v. I know it's tough. It's going off screen. It's so tough. So long. Let's see what I got here. Let's see if I did that. By uv dot v. I didn't want that, did I? What did I want? Well, I'd hate to type that thing in again. I just use my cursor to do that. And I want to do n, approximate it, but I want it in degree mode. So times 180 divided by pi dot n. Remember, think an error, it's not going to blow up. And what do I get? I get 112.166. You notice same answer that the key says. Same answer. Okay, let me just repeat this to you. It's really important you can do things by hand. You will never, ever get to a computer unless you can do things by hand. You got to do simple things by hand. Then you build on the simple stuff, like a building block. These simple little things that you're doing by hand, all of a sudden could grow into really big things that you can do by hand. At some point, though, it's going to get so complicated, you're going to need a machine. Before you get to the machine, though, make sure you can do simple things first. We typically give you some code tidbits. I do want to go to a website, though, and I want to point out the website I want to go back to. Just give me a second to do so. I want to go to the website that I mentioned to you in the past, which is sage.mathography.org. All right. Now, I did talk about my guidebook. It's a short guidebook. It's specifically designed for ECC students. My guidebook was not edited, though. It's me writing Yeah, there might be some errors in it. I don't know. People never tell me about my errors. Actually, you know what? A guy did write me from university. He used the book and he pointed out there was an error in the book, and that doesn't correct it. But he actually used the book for his students. He thanked me for it. He said his students did well with the book, but there was an error in one line of code that he told me about. And he was very generous. He told me what the line was and he communicated with me. So what I want to point out, there's another series of website with a bunch of other published materials. I just want to talk about this Gregory Bard's website. This is Gregory Bard's website. If you scroll through Gregory website, he actually wrote a book that was edited and is being sold on Amazon for a big price. However, he actually got the publisher to allow him to distribute the book for free online. And when I say that, the free version online is a PDF. All right. So if you scroll through this thing over here, you're eventually going to see that he has a link to a color version of the book. Let me click on that. It's going to download it. I think you just saw that go there. It's going to open it up. This is what the book looks like. I think this book's rather old. I think it's back to maybe 2010. It's an old book. All right. Sage has come through a lot in 10 years, by the way, or more than 10 years, more than a decade now. But anyway, it's a good book. All right. Now, what do I mean by good book? If it's read. All right. Most people don't read books. What they do is they kind of look at it, say, that's too long for me to look at. But what does he do? He actually, welcome to Sage. Sage is a calculator, common functions, trigonometry, graphing, a lot of stuff, all the way up to, taking derivatives, plotting functions and their derivatives, projects that you could do, projects from microeconomics, biology, industrial optimization, chemistry, a lot of different things, advanced plotting techniques. You look at all the pages, 116. Boy, you could go through that table of contents until you're blue in the face, but here's the deal. It keeps going on and on and on. Eventually getting to differential equations, Laplace transforms, yada, yada, yada. Does this guy ever stop? Oh, Sage and Python, I've often mentioned that. Loops and accumulators, blah, blah, blah. Boy, it's really an extensive system, isn't it? And he's just touching on it. He's just touching the surface of it. That's all he's doing. It's an introductory course for undergraduate students. But by the way, the book keeps going on and on and on until you get to the final page, which is somewhere around 300 and some odd pages. It's free of charge, though. Like a lot of things, they may be free, but not everyone's using it. Some people are using these things to move forward, to learn, to move forward. We want you to get into that mode too, to think about moving forward. Thank you.